This video is about duration, intensity, and training on fuel use. How does exercise duration affect fuel use? At rest, we're predominantly using fatty acids to generate energy and not using very much glucose and especially very little amino acids. However, if we go from rest to movement, within a start of an activity up to 20 minutes or so, we're really going to shift to using a lot more glucose for energy needs. And you can see we'll use some creatine phosphate, which is present in the muscle cell, can give a short amount of energy. And then we will use fat and amino acids less. So again, within 20 minutes or so, start of an activity, we're primarily using glucose. If you continue the activity, so after about 20 minutes, we really start to use both glucose and fatty acids as primary energy sources and really minimally use amino acids. How does exercise intensity affect fuel use? When we think about intensity, think of lighter, moderate intensity, and then high intensity. So lighter, moderate intensity, that would be when you're exercising, you're still able to have a conversation with someone. But what happens with fuel use in this situation? We can use both glucose and fatty acids for energy. And essentially this is because we have adequate oxygen availability that can get to the muscle and meet the demand of energy for the sustaining movement of the muscle. This use of both glucose and fatty acids and having oxygen present to fully metabolize those is the aerobic part of metabolism. And this aerobic part of metabolism is evident in light to moderate intensity activity. So these images here are just showing you what's happening. So fatty acids are being released from fat cells, and then along with use of oxygen, we can actually break down those fatty acids for energy. We can also use glycogen stores and break off glucose molecules. So you might remember from chapter or lesson 4, the glycogen are linkages of glucose molecules together in a branch chain. So we can pull those glucose molecules off several areas of this branch, and then we can get it from the liver, which then will send it to the blood and to the muscle. We also have glycogen stores within the muscle, so we can actually have glucose coming from the muscle as well. This glucose can be converted to a compound called pyruvate, and with the presence of oxygen, it can go all the way further and break down and create energy. So the aerobic part of metabolism generates a lot of energy. So that's why energy is bold and it's in a bigger figure or shape here on the slide, is to show you that it's a lot of energy. There's one other place we can generate energy. So glucose being converted to pyruvate generates some energy, but it's not as great as the energy we produce when we have this oxygen around or aerobic part of metabolism. What about on high intensity? So think about this as like a 100-meter sprint or a fast break in basketball. And in this case, we're in the anaerobic part of metabolism, meaning that oxygen cannot get from the muscle cells adequately to meet the demand of the muscle to sustain the movement. So we're only going to be using glucose. You really can't sustain a high intensity level of activity for longer than 1 to 3 minutes. After that, the muscle will fatigue and it will slow down to a more light or lower moderate level. So what's happening here is we're still having glucose around, but we're just converting it to this pyruvate. We're generating some energy, but definitely not as much energy as what we saw in the previous slide. The other thing to mention here is the immediate muscle fatigue that occurs is related to lactate building up within the muscle tissue, and this leads to fatigue. However, you might wonder, well, what really leads to the soreness the day after? Is it lactic acid buildup? And the answer is no. Muscle fatigue or soreness the day after is related to micro tears to the muscle fibers and not to lactic acid. So after you engage in something of high intensity, again, remember it can't last more than a few minutes, your body is going to take that lactate to the liver and it'll be converted back to glucose. So you're not going to see lactic acid build up for a long period of time. How does exercise training affect fuel use? What's amazing is that the muscle really adapts. As the muscle becomes trained, you can store more glycogen, which can be really helpful for an endurance athlete. needing those stores to be around. The other really amazing thing is that a trained muscle actually is more efficient at using fatty acids for energy. So why is that a benefit? Well, that allows the glycogen to last longer, essentially. So you're able to burn more fatty acids and spread out the use of your glycogen a little bit longer. And you're still going to need to follow all the nutrition recommendations that we recommend for endurance sports, but at least your trained muscle are being more efficient at fuel use. If you have any further questions, feel free to reach out to me or to the TAs.